While watching this video, you're going to need to be taking notes and trying to work through those examples. If you don't have your notebook out and a pencil, please pause the video and get that now. In this video, I'm going to be explaining how to multiply fractions and mixed numbers, including whole numbers as well. When it comes to multiplying fractions, it's actually easier than adding and subtracting, because here's the surprise. You don't need a common denominator. It's not necessary. You can just start your business just as the fraction is. Okay, so I need you to write that down to make sure that you're clear. I often see students taking the struggle and the time and the effort to find common denominators. They multiply, the numbers get big, then they have to simplify, and it's just a lot of spinning your wheels with numbers when you don't have to, okay? So let's keep it simple and not fuss with a common denominator. In fact, I'm actually going to show you a way to make canceling and reducing before you even start working on your problem. Let's just first look at how to multiply a fraction by a fraction. Again, at any time, if I'm going too fast, please just pause the video. You can back it up and watch it again. Let's start with this first fraction over here. This is 2/3, sorry my 3 is a little sloppy, times 4/5. Now we don't need to fuss with common denominators. I don't need to multiply the first fraction by 5 and the second times 3, because we're just going to multiply straight across. And 2 times 4 you all know is 8, of course, and 3 times 5, there's your common denominator. You are done. That's that easy. So in example number 2 here, you can see it's going to be 6/14. But you're not done with this one because they're still both even. Okay? So yeah, you have to divide both top and bottom by 2. And you're going to end up with 3/7, which makes sense if you come over here and think about this first fraction. If you have 6 out of 7 pieces, and now you're going to take half of that, doesn't that make sense that you would end up with 3 out of 7? Sure does. I love easy fractions that help build those foundations of understanding, because when the numbers get a little crazy, it's really kind of hard to understand and see exactly what we're doing here. Now, I'd mentioned that I'm going to show you how to reduce before you multiply. And that's going to be really fantastic, especially if numbers are big. Called cross-canceling. And now you don't have to do it this way. If you want to multiply and reduce later and that makes more sense to you, then please, please, please do that. If you want to give this a shot, homework is the place to do it, right? That's where we practice. So just kind of try it out a couple times. Let me scoot this up. And let's look at our examples. Okay, so this first one over here, we have 5/12 and 3/10. Now this is cross-canceling. So we're going to look at the numbers that are sort of across in a more diagonal way than just straight across from each other. And we're going to look at 5 and 10 as if it was its own fraction. So we're going to think about 5/10 would reduce, quite obviously, let me get this out of my way, it would reduce to 1/2, right? Because you would divide the top by 5 and the bottom by 5, and you would get 1/2. But I don't want you to go ahead and have to write all this stuff out. I want you to be able to just think that way. So when we come to our fraction, we can just think 5 goes into 5 once, 5 goes into 10 twice, and I'm left with a 1 and a 2. Now you can see you can do the same thing with the 12 and the 3 here. 3 goes into 3 once, 3 goes into 12 4 times, and now you just multiply what's left. I have 1/1 and 1 times 1, I'm sorry, not 1/1, I have both 1's on top, so 1 times 1 is 1, and I have 2 times 4 left on the bottom, which is 8. So I'm going to end up with 1/8. If that was too confusing, or you're not sure really how that worked out or why, let's take a look at what we would have done without canceling. 5 times 3 is 15, and then 20. Now you know these are both divisible by 5 because of the rule, so let's divide this by 5. We know that's 3 twice. Is that right? No, it wouldn't be 25, would it? Of course, I can't think on a video, so 5 goes into 12 twice. Oh, 24. That makes more sense. I was looking at that. Okay, so 2 times 5, 10. So if you're just as confused as I am, even more proof that showing your work really helps correct some of those mistakes. You would get 3 over 24. And then you can very clearly see that you should end up with 1/8 because you're dividing both top and bottom by 3. Okay, let me get some of this work out of our way. So we ended up with 1/8 doing it either way. And I'll go over that other way again real quick. So 5, I cross canceled those two. 5 goes into 5 once, 5 goes into 10 twice, 3 goes into 3 once, 4 times. I'm left with 4 times 2 on the bottom. I'm left with 1 times 1 on the top. There we go. Now, for a problem like this, it's really not that bad because it was easy to simplify. But let's look at this one over here. Okay, now you have 8 times 21. Yuck, that's going to be 168. And 7 times 4 is 28. You can start by 4s, start reducing by 2s. There's going to be a lot of reducing to get this down there. So if I reduce by 4, well, guess what? I'm right back to 7 on top. But the bottom is going to be 21, I believe, right? No, 41. Sorry. 4 goes into 16 4 times. Oh, wow. I'm making lots of mistakes. Well, that's okay. Math teachers are human too, right? Okay, so let's, again, trying to do stuff in my head. Divide by 4 goes in 42 times. Well, if you know your 7s, you know these are both divisible by 7, and that is 1/6, okay? Not too bad. I clearly would have made a mistake right here, personally. Maybe you were feeling a little sharper than I am right now, but I don't want to take the chance. So I'm going to do what I think is quite a bit easier. I'm going to cross, cancel, and you can see 7 and 21 are across from each other here. Again, if I think about it as 7 over 21, I would reduce that to 1/3. I'm dividing both of those numbers by 7. And 4 and 8 would reduce to 1/2. Wow, that is so much easier than what we just did. Okay. There's other videos about cross-canceling. If you need to go back and watch my steps, that's the greatest thing about having these videos and recording the lesson. Okay. Let's move on and talk about multiplying fractions by a whole number. You need to know this. 1 every single time. It doesn't change the value of that number, but we can't really work with it as is. For example, 1/4 times 12. You would have to rewrite that. Now, some of you can look at that and say, well, I know if I take 1/4 by 12, or I'm sorry, 1/4 of 12, that would just be 3. Well, yeah, if you do this the regular way and divide the top, you would get 12 over 4, multiplying straight across, which then you divide the top by bottom to reduce, you would get 3. Let's see if we can cross cancel this thing as well. Take some of this out. Actually, I'll just rewrite it. I have 1/4 times 12 over 1. If I cross cancel, I look at these two. 4 goes into 4 once. 4 goes into 12 3 times. I just end up with 3 over 1. You don't even need to write it that way. You could just at this point say, well, I have 1, 1, 1. All I have left is this 3 on top. If you know that all you have left is 1s on the bottom, you can skip this step right here. I don't think that's the biggest deal in the world. Okay, so fractions are real easy. You just put the whole number over 1 every single time. It doesn't change the value, but it changes the form so we can work with it, okay? I'm not going to waste your time with too many examples on that, because once you put this over 1, you go right back to these steps of just multiplying straight across. Okay. Are involved. If you have, oops, here's another one. I guess you would just put this over 1, but now 6 and 9 are both on the top, so you cannot cross cancel. Oops. You can't cross cancel anything. You just have to do 6 times 9, which is what? Now you can simplify that to a whole number. I'm sorry, a mixed number. 7 goes into 54. Not quite 8 times, I guess only 7. 7 times 7 is 49. You would have a leftover of 5 sevenths. There's nothing to reduce there because nothing across from each other. 7 and 9 don't have any common factors other than the number 1. That doesn't do anything for us. Same with 6 and 1 here. Okay. Now mixed numbers. Here's some big blue writing and something's underlined and capitalized. Must change it to an improper fraction. With adding and subtracting, you could kind of take off those whole numbers and deal with them. You cannot do that with multiplying. You can't just put 1 over here, multiply your fractions, and call it a day. That's not going to work out, because if I did that, I would have, let's see, ooh, I'm going to cross cancel these 3's. I'm ignoring this 1 right here because I already took it off. I'm going to try to write my answer here. So I had 1, 1. This is not 1 1/2. Okay, let's figure out why. Let me move all my red stuff over. Ooh, or just move the blue over. That way I can erase. We'll bring this back. Whoa. I have to change it into an improper fraction. So I'm going to do that. Multiply and then add. So now my problem is 3/4 times 5/3. If you are really loving this cross-canceling thing, you're going to see that the 3 on each side will cancel out. But let's just do this. 3 times 5 is 15. 4 times 3 is 12. You're going to get left over. You're going to have the whole number of 1. So that was right. But our fraction is going to look a little different. 3 over 12 is going to minimize to 1 and 1/4. Okay, and I think on the other one I got 1/2, so I was off. Okay, as these whole numbers change, so will the value of the whole number that's left over in the answer. Let's go back and see what that looks like. At this point with the cross canceling, you'll see that it's quite easy. I divide both those by 3. I end up with 5/4. You end up with 1 and 1/4. Okay, I definitely love that cross canceling method. Now, you do have to go to improper fractions, but again, you don't have to fuss with the common denominators anymore. So actually finding that is not that big of a deal. So let's try this one. Now you can try it by disconnecting and doing 3 times 4 is 12 and see what happens and compare it to what I'm going to get now. So if you want to do it that way and give it a shot, pause the video, but I'm going to go ahead and do it the way I'm supposed to the first time. That's 9, so I'm going to get 11/3 with my first one times 8 times 4 is 32, so 37/8. Ooh, that's ugly and nothing really cross cancels, does it? Why would I choose this example? Okay, Let's give it a shot. I know I have 24 on the bottom. 37 times 11. That's pretty easy to figure out, right? 407 over 24. Well, now I need to reduce that thing. I'm just going to think about quarters. 24 is close enough to 25. If there's 4 quarters in $1, there's 16 quarters in $4, right? What's that mess? $384. Can I get any closer? Could I have gone with 17? I don't think so. I think I would have been over because I would have an 8 if I had another one here. Okay, so my whole number now is 16. And my leftovers are, I'm sorry I have to keep erasing this work, but I'm sort of running out of room here. 384 was my result, so I want to keep that. Difference is 3. Oh, 16 and 23 24s. Okay. 3 times 4 we said was 12. Somehow we got another whole number out of this and made this basically being multiplied by 4. 4 times 4 is 16. So you're not going to get the correct answer if you don't go with the improper fraction, okay? There's only a couple of these. Now let's look at mixed numbers and a whole number. I'm going to erase this big hot mess up here so we have some room. Sometimes that's just a lot to look at. My board's not keeping up with me as much as I would like, but that's okay too. Okay, so now I have 7 5/8 times 4. How many of you are going nuts over that red mark that's down there in the left corner? I may just leave it there to bug you, but I won't. You're welcome. Okay. Again, what do we do with whole numbers? Put them over 1. Make them improper fractions. That's 56 plus 5. Ooh. 61/8 times 4 over 1. Well, the good thing is I don't have to multiply 61 times 4. And I really don't want to, so that's a good thing because look, I would have 4 over 8. 4 goes into 4 once, twice, 61 over 2. Now I can handle that. I can do that division in my head because I know that 2 goes into 61 30 times with a remainder of 1. Okay. And I know it's weird because you're like, wow, it's only 7 times 4, but it's also 4 times 5/8, so that's going to give you a whole lot more whole numbers. 7 times 4 is 28, but you also have to multiply 4 times 5/8. Okay, and again, if I set this, show you, I'm going to get 1/2. So that equals 5/2, right? I'm going to stop writing crookedly and bring that up over here. 5 over half, or 5/2 reduces to 2 1/2, right? I was going to do it at decimal, so I put a point. Just erase that little decimal point. It's going to drive me nuts. So now if I took 2 1/2, which was my result of multiplying 4 times that fraction, and I added it to this, which was the result of multiplying the whole numbers, 28 plus 2 1/2, guess what? Okay, so that's actually what we will talk about in 7th grade called the distributive property. What the distributive property looks like, and I'll erase this big hot mess. Now that you saw that the answer answers are the same, is if there are basically two parts to this first number, the definition of a mixed number is a whole number plus a fraction. So we look at this as a addition problem. And it's being multiplied by 4. So we want to multiply this entire thing times 4. And to make sure that we multiply the entire thing times 4, we put the parentheses. And then we distribute, which means to give out, what we're multiplying. So we multiply that, we get our 28, and then we multiply that, which we know that that was 2.5, and then we would add these together. Maybe you like that, but it is really gruesome when you have to do 7 times 4, 7 times 1/2, 5/8 times 4, 5/8 times 1/2. It gets ugly really quick, and that's not just distributing. That's something called FOIL, which is you first do your inner numbers, your outer numbers, your last numbers. It's so much easier to convert to a mixed number than just multiply straight across. Canceling will be a godsend. I hope you play around with it on your assignment. Now there is a MathXL that supports this. It's not too long. There's only a handful of problems. We will be discussing this in our next class a little bit further just to make sure I get to answer all of your questions.